Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 academic students who are studying the measurement and geometry unit. This is part 1 of that unit where we study two-dimensional measurement. So the items we're going to look at are a review of the basic formula for shapes, the Pythagorean theorem, and a look at right triangles, composite figures, and some thinking and application problems. And this is the first video of this particular part of the unit. So let's have a look. So here are some diagrams of some of the basic shapes. So I've given you a rectangle, a trapezoid, and a circle. And one thing I want you to remember is that the formulas that we need in two dimensions relate to perimeter and area. So we know that perimeter is a measurement of the distance around an object. I usually think of it as if you were to walk around this shape, what is the total distance you were to walk? Area is the distance filled by the shape, or as I like to think of it, if I had to cut cloth in this shape, it's the amount of cloth that I would need, or the amount of cloth that I would have to cut. So in terms of the formula, you should remember oops, that you are given a formula sheet for this unit. So every quiz or test or the EQAO itself, you'll be able to have this formula sheet with you. And that means you don't have to memorize any of these formula. So let's look at them a little bit. So for a rectangle, here's the formula for perimeter. You're given length plus width, or of course 2 times length plus width. But really, this is a very useless formula. If you understand that perimeter is add up the outside edges, you certainly don't even need to reference this sheet. And of course, I think we probably all know that area of a rectangle is length times width. Parallelogram, again, the formula for the perimeter of a parallelogram, fairly useless. You just add up the outside edges. The area of a parallelogram is sort of like the area of a rectangle. It's base times height. However, please remember that base times height are always defined as two lines that meet at a 90-degree angle. So the height of a parallelogram is never going to be one of these slanted edges, but instead it's going to be an internal line that meets at 90 degrees. In fact, if these slanted edges were to meet the base at 90 degrees, then it would actually become a rectangle instead of a parallelogram. So make sure that you understand the concepts of base and height. Again, base and height are two lines that meet at 90 degrees, one of which is usually a side of the object, and the other one is an internal imaginary line. And that's especially true if you look at triangle. So the triangle, again, useless to look at the perimeter. We just add up the edges. But to find the area of a triangle, it's base times height divided by 2. And again, you can see that we called this base and we called this height, and they met at 90-degree angles. So those are the two sides that multiply to give area. And then, of course, divide it by 2. Don't fall into the assumption that base has to somehow be the one that's on the ground or the one that's lowest to the ground, because that's not true at all. For example, for this particular triangle that I've just sketched, if I draw this, then now I have a base here and I have this height. So don't assume that the word base implies bottom of, meaning in terms of its physical relationship to the piece of paper. That's not what base means in a mathematical measurement setting. The concept of base and height is also important when we look at a trapezoid. Again, useless to look at perimeter's formula, but the area formula says add a plus b together, multiply that sum by height, and divide by 2. And again, you'll see that the height is this internal perpendicular line, and in a trapezoid, it's perpendicular to both a and b. So it's sort of like finding the average of those parallel side lengths. So a plus b divided by 2 is the average length of those sides, and then multiplying that by the height. Now the final shape that's on this formula sheet is the shape whose formulas are probably the ones that we actually need this sheet for, and that's a circle. And of course, a circle is always that shape with slight differences. For example, we don't actually use the word perimeter when we talk about a circle. A circle perimeter is given a special name called circumference. And there are two formulas for finding circumference. One is pi times diameter, and diameter being the full distance across the middle of the circle. Or if you don't have diameter, you can certainly use 2 times pi times radius, radius being the half distance across the circle. And of course, the formula for the area of a circle is pi times r squared. And in a previous grade, you may remember this as pi times r. But of course, now that we're in high school, we're very comfortable with exponents, so we know that it's just pi r squared. Okay, so now that we're a lot more comfortable with those formula, what I want you to do is I just want you to take a couple minutes and using those formula, I want you to find the area and the perimeter of each of the shapes that I have on this page. So press pause in the video and do that math. And then when we come back from pause, you'll see my answers for perimeter and area of each of these shapes. Okay, so if you look at the rectangle, I found a perimeter of 38 meters and an area of 84 meters squared. Please make sure that you're writing the units, otherwise you don't have the correct answer yet. For the trapezoid, a perimeter of 42 centimeters and an area of 81 centimeters squared. For the circle, I found a circumference of 37.68 millimeters and an area of 113.04 millimeters squared. But as a general rule for this unit, you should round to 1 decimal place. So my answer for circumference should really be 37.7 millimeters, and my answer for area should really be 113.0 millimeters squared. Again, so make sure that you are rounding to 1 decimal place, and certainly if you need any assistance with rounding, please make sure you come visit someone in the math office because it's a very important skill that you're going to have to use throughout this unit. Okay, so let's move past basic shapes because to be honest with you, we don't deal with basic shapes just on their own very much in high school. We look at more complicated issues that relate to basic shapes, but not the basic shapes on their own. So the first thing we have to do is we're going to look a little more closely at triangles, and in particular, we're going to look at the Pythagorean theorem. So again, this should be a review from a previous grade, but let's make sure oh, something's happening. Okay, no worries. Weirdness. Okay, so here's what you should know about the Pythagorean theorem. It's a theorem that relates only to right-angled triangles. So make sure that if you want to use the theorem, you see this 90-degree symbol or this perpendicular symbol. And it's a theorem that relates to the side lengths of a right-angled triangle. Okay, so now that you know that, here's how the Pythagorean theorem should have been discussed with you in a previous grade. You should have been told that the Pythagorean theorem is an equation that tells us that the length of the hypotenuse squared is equal to the length of the base squared plus the length of the height squared. So you'll notice again that we have base and height, and that those are the sides that meet at this 90-degree angle. And again, that's a really important concept that you know, that using the words base and height mathematically suggest, imply, and tell you that there is a 90-degree angle between the base and the height. Okay, so hypotenuse squared is equal to base squared plus height squared. Now, you probably actually know the formula like this. C squared equals A squared plus B squared. So that's the formula most of you have memorized. And if you don't, well, you're going to have to memorize it because it's not on your formula sheet. And the most important part about using this formula is remembering that the C refers to the hypotenuse. So it's always the hypotenuse that's over here and the other two sides that are added together. So the way that I usually teach, if I were to teach this to a student for the first time, is I would tell them, look at your triangle, find the right angle. So there it is. Once you have the right angle, draw a line through it and you'll touch the hypotenuse. And that is labeled as side C. The other two sides, it doesn't matter which one's A and which one's B, just label them. And then you have a properly labeled right angled triangle, and you can now substitute values into this formula. So let's practice doing that. So for example, here's a right angled triangle. So I'm going to draw a line through that right angle, and I've touched now the hypotenuse, which is labeled C. The other two sides, I'm just going to call them A and B. And the question says, find the perimeter and the area of this triangle. So let's talk first about perimeter. Again, I'm not going to look at that formula sheet. It's pretty ridiculous to look at the formula for perimeter when you know that perimeter is equal to the sum of the sides. So one side is 25, one side is 10, and the other side, I don't know it yet. So usually I'm just going to leave a blank, and that's to remind myself that perimeter is just add up the sides, and I happen to be missing a side length. So my next question is, how am I going to find this side length? Well, obviously, that's the hypotenuse of this triangle, which means I'm going to use the Pythagorean theorem. So c squared equals a squared plus b squared. So c squared, again, I don't know what the hypotenuse is, but I do know that a, we called it 10, so 10 squared plus 25 squared. So c squared equals 100. 10 squared times 10 squared is 100. Plus 25 times 25 is 625. So c squared equals 725. Take the square root and you get 29.9. And again, be careful that you round to one decimal place. Sorry, 26.9, not 29.9. I misread my calculator. So 26.9 is the length of that missing side. And it would be in centimeters because all the other measurements are in centimeters. So I'm just going to put a box around this because this was a separate piece of math that I did. It was the math where I tried to find the length of the missing sides. And now I'm going to go back to my perimeter statement and I can fill in that blank. I now know that the missing side is 26.9. Make sure that if you're doing the math and you're kind of following my steps, don't just tell your teacher that the value is 26.9 if you haven't shown them the math that you did to get that value. Certainly you can show for fewer steps than I've shown you, but you have to demonstrate how you got that answer. And so finally I can now add together and tell you that the perimeter is 61.9 centimeters. We also needed to find the area of this rectangle. So we remember that the area is base times height divided by 2, or if you don't remember, that's why you have a formula sheet. But we do remember, most importantly, that base and height are the two sides that meet at a 90-degree angle. So this side and this side must be base and height. And it completely does not matter which one you think of as base and height, as long as you know that you have to multiply 10 times 25. So 10 times 25 and then divide by 2 is 125 centimeters squared. So there's my perimeter, there's my area, and here's the math where I use the Pythagorean theorem to help me. So on this question here, again, it's a question involving both perimeter and area, and I'm missing a side length. So what I want you to do is I want you to pause the video and see if you can get the answer without me. Okay, so I'll meet you on the other side. Okay, so as I did in the other question, I started by looking at my triangle from a perimeter perspective, and I knew that I would have to do 11.8 plus 32.3 plus this missing side. So I've written perimeter with that missing side, and then to figure out what that missing side is, I'm going to have to use Pythagorean theorem. Now in this case, keep in mind that I know what C is because I have the hypotenuse of 32.3. So therefore, it's A and B. And I usually label A as the thing I know and B as the thing I don't know. So here I have found the length of the missing side to be 30.1 by using the Pythagorean theorem. And you can see here that because I knew the hypotenuse, then at one step there was a subtraction involved. So that gives me 30.1 for my missing side. And so altogether I can tell you that the perimeter is, so the perimeter is 74.2. To find the area, I can now just say that base times height is 11.8 times 30.1 divided by 2. And so that gives me an area of 117.6 millimeters squared.